Hey everyone, hope everyone's having a good day at Octane Live this year. We're gonna have a really fun presentation today, and I want to start with, I guess you could say it's a little bit of a joke, and it's funny because it's true. Has anyone heard the expression, the S in IoT stands for security? The obvious joke there is that there is no S in IoT. And this begs the question, why still in 2020 can we not trust IoT? My name is Matthew Gregory. I'm the CEO and founder of Ockam. Ockam is a tool company. We build tools for developers, and those developers are the ones that are going to usher in this new world of interconnected devices that can actually trust each other. So we're building some very foundational technology for this effort. A couple terms you'll hear me talk about in this presentation. When I say IoT, I kind of use that synonymously with edge and distributed systems, whether it's Linux boxes to edge, routers, computers, mobile phones, industrial automation equipment, even sensors. So this is kind of a broad swipe at the generic term IoT, and not specifically just the connected devices in our houses. During this presentation, I'm going to go through five key points. I think just to give everyone a little bit of context, I'll give you a little bit of background on my journey that got me to this moment. We'll go over the root problem in IoT. I'll address why open source is coming to the rescue, if you will. And then we'll go through a case study where I'll join the root problem in IoT and the open source solution. And then finally, I'll give you one thing to take home with you to make this presentation something of value for everyone. So my journey to where we are today started off right after I graduated from college in the late 90s. I spent about a decade building instrumentation systems for America's Cup and Volvo Ocean Race boats. So it is very much analogous to auto racing, a lot of sensors, data collectors, real-time analytics tools, and we were moving information around and trying to make real-time decisions during races. I then moved out to Silicon Valley, and that was a pivot in my career from building instrumentation systems to building tools for developers. I built a weather API. If you've ever seen weather on your phone, chances are it uses that API to get its data. Then spent some time in the early days at Heroku, another developer tool company in the early days of AWS and cloud. Then I spent some time at Microsoft working with right after Satya took over there, helping them pivot to the open source strategy that everyone knows and loves today. And along that journey, I kind of came full circle back to this question of why is it so difficult for devices at the edge and outside data centers to work together? And I started looking at this concept of interoperability and what was the core blocker for why devices cannot talk to each other and interact in a functional sort of way. What I quickly realized was that interoperability is really underpinned by trust. If you get a message from somewhere on the internet, you need to trust that that message has not been tampered with and is a piece of information you can trust. But I started going down down the rabbit hole of what is trust in edge and IoT, and realized that trust is underpinned by identity. It's critically important as a first step to understand which device is sending or which application is sending a piece of information that you're trying to act on in some sort of distributed system. Now, fortunately, the hardware community is helping us in this regard. They're new chips. We have them in most of our Android or iPhones, in MacBooks, but there are all sorts of companies that are building, creating the ability to store a cryptographic key in hardware. And what this does is it creates a root of trust, because that key is generated in the device and it never leaves the device. You effectively have to destroy the device to maybe try to go figure it out. And what that does, it creates a world where we now have self-sovereign identity for things or devices, instead of relying on certificate authorities or some other attestation that's coming from the outside for that device. The device can self-generate an identifier and have a self-sovereign identity. And there's a great project I encourage everyone to look into coming out of W3C called Decentralized ID or Decentralized Identifiers. They're doing a lot of groundbreaking work in this area for how those identifiers will work. So in this problem of sharing information or data between cloud and the edge, we have this interface where we have had 10 years of fast forward development in open source or open core software that are driving many of the cloud services that we know and love today. You know, whether that is Okta or Mongo or Postgres. There are all sorts of open source projects that have turned into great commercial cloud services, and that most of those are running on the internet today and are very familiar tools with all of us. The problem is on the edge side, there's still a lot of proprietary software, and specifically with the way that instruction set architectures works. This is the software that's directly talking to the hardware. That is still kind of a proprietary world, and that's kind of where the crux of the problem is. Fortunately, this playbook we've seen in the cloud services, and even though, in my opinion, the edge in hardware and IoT is about a decade behind cloud innovation, we actually have this really great playbook for how to innovate very fast, and that is around open source. So what I want to do is go through a little bit of a baseline with everyone on why open source is so great, before I go into the case study that I had mentioned earlier. And open source is great because of ecosystems. A lot of people think of it as technical or potentially even software, but free. I would encourage people to look at it through the lens of ecosystems, and that is the real power of open source. So let's take a look at what that actually means in practice. And I'll start in the abstract, and we'll kind of keep sharpening this concept as we go forward. So if you think about the world as having two halves, there's, let's say, an open source community side, and then there's a commercial entity. And you see this pairing in most of the successful open source projects, where you're going all the way back to like Linux and Red Hat, to some of the newer technologies that people are using, say like Kafka and Confluent, for example. Ockam is in this similar state. We have commercial side to what we do and an open source side to what we're working on. If you think of these two halves of a open source piece of software, essentially you have the commercial side sponsoring the open source community and its development, and the open source community is partnering with that commercial company to drive innovation forward. And what that combination of sponsorship and partnership between commercial and open source ends up getting you is innovation on the business side and on the technical side. Specifically, you can start on the open source side. We have much faster innovation because the barrier to participate is so much lower, and there are more eyes and ideas on any particular idea. And effectively, the innovation is not limited just to what that commercial entity is driving forward in their product roadmap. Adoption is very frictionless. Most code is available on GitHub or GitLab. Ockham's code is available on GitHub, for example. So it's very easy to fork a project and incorporate it into whatever you happen to be building. I strongly believe that open source improves security. To having security kind of wrapped in a black box and where the code is not seen and you just have to trust what happens in the black box is, I think, nebulous at best. By having more eyes on a piece of software and more people using it, the bugs or the vulnerabilities are surfaced quickly, and someone else doing something completely different from what you're working on might actually find a problem far before you do, or where you might not even have the expertise on your team. Submit a pull request with a patch, and that hole is fixed. And this is probably one of the strongest pieces around open source with ecosystems are these unbound integrations. Because of APIs and interfaces that are built into software, anyone can use that interface to integrate whatever they're working on with another project. So this creates a great, amazing graph relationship between pieces of software, and you can really take a piece of software and build whatever sort of integration you want onto it for your specific use case. And that is only limited to imagination, not necessarily the commercial aspirations of the project. On the business side, you effectively see three business models that are either some companies are just doing one or two, or sometimes even all three of these. You either have enterprise support. Red Hat and Linux is a canonical example there. Open core licenses. These would be where you are getting the software and running it yourself, and there is usually some bit of proprietary software that goes with that open source code. Maybe it's a dashboard or some role-based access control. And then there is the final one. There is software as a service. So this would be any of the situations like for example, GitHub is a good example of this, where you have a core open source piece of software and it is delivered as a service in a hosted cloud environment. So the maintenance of the code, the user experience, the infrastructure that code is running on is all abstracted away to the end user. They're either accessing it through some sort of web portal or maybe even an API in case of things like databases. So now I want to go through a specific case study, and I'll speak to something I know best, which is Ockam, because these are the things that I'm thinking about every day. But I think that using this example is directly applicable to all sorts of other use cases. So, and I think that you'll see with the way we are building our open source activity at Ockam that it is ecosystem first, and that is where we are focusing all of our energy. So what does that look like in practice? Effectively, this is a diagram of our world. As I said, Ockam is building tools for developers. They aim to build trustworthy IoT applications. So we have this messaging layer that effectively sits between the cloud and hardware at the edge. And that software manages the identifiers and the chips down at the bottom level and establishes connection between the hardware at the edge and the cloud, and then sends trustworthy messages between the two. We effectively call this a trust architecture, where you have trust up and down your stack. So you can imagine a scenario in our world. Let's say take our partners, Okta. You could have an application, a business level application. Let's say you're in the oil and gas industry, and you are using Okta for identity access management and role-based access control. So employee at that that has the proper access to control valves out in West Texas can submit at the application layer a control to drive that change on that actuator on that valve. That flow of information is trusted down to the device out in the field. That valve can trust that data that's coming from the cloud. The valve opens, and then maybe that device is running an ARM processor with some microchip key vault storage module, and it's connected to an InfluxDB time series database. So there's an agent that Influx has called Telegraph that is running on that processor. It is then sending messages to InfluxDB, and it is establishing authenticated connection with that database and signing messages with its cryptographic identifier, so that the server side can be 100% certain that that message originated from the device it thinks it has, and can then act on that data. So the question here is, what's in it for the community? Why would someone want to join this ecosystem? And if you think about it through a business development lens, because all the companies in our ecosystem are commercial enterprises, we can think of this as like in the classic business development terms. So like, what are the gives and gets? Why would someone want to do this? So if you're a maker of hardware and you're installing your hardware into edge environments, and the core thing you're trying to do is either get data from the cloud or send data to the cloud, maybe if you're a sensor, what you're looking for are strong connections to the cloud. So fortunately, the cloud has mature cloud native code bases. There are millions of open source developers, and the hardware companies acknowledge this, and they are actively trying to build developer relations communities. On our side, when we talk to Ockam customers or our cloud partners, we're bringing what edge providers would call sockets, effectively use cases. We can help them with either SLAs and support. We have several features that we can that they can add into their software. They ship in an OEM fashion. And we have another product called the Ockam Registry that is of interest to cloud provider or edge environment providers as well. Now, what does the edge ecosystem give back to both the commercial side? Obviously, on the commercial side, we have business development partnerships and revenue. On the open source side, these edge environments have those critical hardware roots of trust. These are where these cryptographic identifiers are stored. This is really valuable for the rest of the ecosystem. And what they can also do is audit the code in that interface between Ockam and their instruction set architectures. So they have a very clear surface area where they can heavily audit code and make sure that they fix any security issues. And that is something that the open source community doesn't have to worry about. They can trust that those chip manufacturers do the right things. And obviously they're building interfaces and integrations to their features that make it and that makes it simpler for anyone that's building software to interface with those edge environments. On the cloud services side, they're getting a lot too. As I said, they're getting those that trusted hardware. There is a whole another world of developer relations that is focused on IoT, and they get that audited code, so they can trust data that's flowing in on the open source side. And obviously, on our side, we have products effectively similar to what we do on the OEM side with the hardware manufacturers. We do the same with cloud services. We bring those hardware partnerships with us into conversations with cloud service providers, along with use cases. And obviously, we have support and service level agreement infrastructure that we can put in place there. And in return, the cloud service providers flow value back down into the system. Obviously, on the commercial side with business development and revenue for Ockam. And then on the open source side, they already have millions of developers that are very attractive to the hardware manufacturers that they're trying to engage with. So that creates a really easy channel for them to establish communication. And the cloud services, having been around for almost a decade now, they have these cloud native, very well thought through, beautiful APIs that are very developer and open source friendly. So that gives you this wide breadth of integration paths for any of the hardware manufacturers. And essentially, what we are doing is to create an ecosystem between cloud services and edge environments. And ecosystems happen when there's a virtuous cycle of value and trust. Now I want to leave everyone with one thing to take home with them. And that is, if you haven't picked up on it yet, it's that open source is ecosystem first. This is the most important thing in how to think about open source. And specifically, I should also mention what it is not. Open source is not pricing strategy. The point of open source software is not to give it away for free. It's to create an ecosystem, and that is job one. There's a book is part of our reading list at Ockam that I really like. Our culture is very much based around a high performance team. There's this great book by Bill Walsh called The Score Takes Care of Itself. And I would encourage everyone to read this book in general. I think people get a lot out of it. But I think that the one of the ways you could read this book is to convince yourself that ecosystem is the benefit of open source, is that all of the whatabouts kind of end up taking care of themselves, like revenue and partnerships. Like if you have a strong ecosystem, the rest is actually quite easy. So that is the big take home for everyone. Check out this book to add to your reading list while everyone's at home doing the virtual conference. I think you'll really enjoy it. If you want to get in touch with directly with me or the rest of our team, we're readily available through simple Google searches. You can reach out to us through our website. All of our code and our project is freely available, and we try to be as transparent as possible with it. So go check it out or ask us any questions, file issues in GitHub. We're on Twitter at Ockam_IO. If you want to reach out to me personally, I'm on Twitter at Little Fortran, and that is a direct line to me, Matt at Ockam.io. On our website, we also have links to get in touch with us, and we also have a community on Slack. We span across 15 time zones at this point in time, so it's a great global community of people, and the link to join our Slack community is on our website as well. And I would love to hear what everyone thought about this presentation. I think we have plenty of time left for Q&A, which is always my favorite part of these presentations. So I look forward to meeting everyone and bring on your questions.